look at how to perform a chi-square analysis. This is going to be a type of hypothesis test that we can do for categorical variables. In this case, my null hypothesis will always be the same. It'll state that there is no association between our two variables. And the alternative hypothesis will always be the same. It says that there is an association between the two different variables. Our test value for this is denoted by the Greek letter chi squared. And for this, we're going to add up a bunch of things. We're going to add up all of the observed minus expected squared over expected. Observed is going to be the data that we're given, the numbers and the values that we are given. And then the expected is calculated using this formula of row total times column total divided by overall total. Finally, our p-value, we'll use r to calculate this. It is always given by 1 minus p chi squared of this test value, chi squared, comma, degrees of freedom. And the degrees of freedom will be given by the number of rows, minus 1, times the number of columns, minus 1. Let's suppose we have this table here that looks at whether a particular person was clinically obese or not clinically obese, and whether they had diabetes or no diabetes. And we want to know if there is an association here. Is there a relationship or an association between obesity and diabetes? These values that we were just given, these are our observed values. And then we need to calculate our expected values. When calculating our expected values, we don't need to worry about a total column. For the first one, clinically obese and has diabetes, we need to multiply our row total by our column total. So 30 times 40. And then we divide by our overall total of 100. When we multiply 30 times 40, we get 1200. Dividing by 100 gives us a value of 12. Next up, clinically obese and no diabetes. The row is 30 and the column is 60. So we need to do 30 times 60 divided by 100. That's going to give us a value of 18. Next up, the not clinically obese and diabetes. That row was 70 and the column was 40. So we need to do 70 times 40 and then divide by 100. I get the value of 28. Finally, my not clinically obese and no diabetes, that row was 70 and that column was 60. So we need to do 70 times 60 divided by 100. And when we do that operation, we get 42. So these are now my expected values. Next up, I need to calculate my test statistic. For that, I'm going to subtract observed minus expected, square that value, and then divide by expected. For the first one, I have my observed as 20 and my expected is 12. So 20 minus 12 squared divided by 12. My next entry, I have the observed as 10 and the expected is 18. So 10 minus 18 squared divided by 18. Moving to the second row, I have my observed to be 20 and my expected to be 28. So 20 minus 28 squared divided by 28. Finally, we have our observed to be 50 and our expected to be 42. So 50 minus 42 squared divided by 42. Typing all of that into a calculator gives us a value of about 12.7. So that is going to be our test value. Next up, we should calculate our degrees of freedom. For this one, we have two rows, clinically obese and not clinically obese. So we do our number of rows minus 1. And then we have two columns, diabetes and not diabetes. So we do our number of columns minus 1, and then we multiply them. 2 minus 1 times 2 minus 1 is 1. Finally, we need to find our p-value. That's going to be 1 minus p chi square of the test value, 12.7, comma, the degrees of freedom, 1. And when we type that into R, we get a value of about 0.0004. Since that number is going to be significantly less than our alpha of 0.05, we will say our alternative hypothesis is true. There is an association between obesity and diabetes.